Welcome to this online revision session for AQA M2. In this session we'll be looking at the January 2011 question 2 on energies. Well, as you can see, we are being given a smooth plane inclined at an angle of 20 degrees, and there is a particle of mass 4 kilograms is going to be released from point A, and it will travel down to point B. Notice the plane is smooth, so therefore there is no friction, so we have no loss of energy due to an external force. So we can just purely analyse the gravitational potential energy and the kinetic energy. Right, so the first part asks you for the potential energy, that's gravitational potential energy, lost as the particle moves from A down to B. So what we need to know is how far the particle will have fallen as it moves from A through B. So since AB is 5 and the angle of the slope is 20 degrees, then the height that's dropped will be 5 sine 20 degrees. So we can then say that the potential energy that will be lost will be equal to mgh, which will be equal to the mass, which is 4 times g times 5 sine 20 degrees. Fortunately, sine 20 is not a straightforward angle, so we'll have to put that into our calculator to come up with the appropriate answer. And so this, if we work it out, works out to be 67.0, and the energy of course is measured in joules. Okay, so 2 marks for that, 1 mark for our appropriate method using mgh and then getting an appropriate value for h to substitute into it, and then 1 mark for obtaining the correct answer. The second part of the question says, hence write down the kinetic energy of the particle when it reaches B. Well, the kinetic energy of the particle at A was 0 because it was stationary, it was released from rest, and so any gain in kinetic energy must be equal to the loss in potential energy. So the kinetic energy, the gain in Ke will be equal to the loss in PE. And of course we know that the loss in PE was 67 joules. So it's the same value. Okay, and of course there's just 1 mark for stating that. Finally it says then, hence find the speed of the particle when it reaches B. Well, as we said, its initial kinetic energy at A was 0. Its final kinetic energy, we can say, is a half mv squared. So a half mv squared, where v is the speed at B, will be equal to 67. We know that n is 4, so v squared must be equal to a half of that value. 33.5, and so v, the speed, will be equal to the square root of that value, which to three figures is 5.79, and that will be meters per a second. Again, just 2 marks for that. Be 1 for your method mark of using the fact that half mv squared must equal 67, and then an appropriate rearrangement and determining the value correctly will give you your second mark. Well, hopefully you found that solution helpful. For further assistance with your maths revision, please go to the Further Maths Support Programme website.